everyone, I am Ayush Prasad of the Funtastic Academy. Okay, so today's video is gonna be about reflection. Now, reflection is, wait. I forgot the quiz question. Okay, so the quiz question was, what is the formula for index of refraction and what is the index of refraction for water? Answer, the formula for index of refraction is C divided by the speed of light in the substance you're talking about. The index of refraction for water is 1.3333333. Infinite threes. Now that the quiz question is covered, we can talk about reflection. Now, I know what you're thinking. What is reflection? And how do mirrors seem to make a copy of with a photocopier? And what does this all have to do with a periscope? Well, I'll answer everything by the end of this video. But first, a quick experiment. Okay, so this is my experiment setup. I got some light passing through these cones and hitting this mirror. Now let's see what happens when we tilt the mirror. Turn off the lights. Okay, now if I tilt the mirror like this, you'll be able to see these light rays that are bouncing off the mirror. They're just these rays that are bounced off the mirror. But these angles of these rays look very peculiar. Is there any way to calculate these angles? Well, there is, and that's the law of reflection. Let me explain. Okay, so here is how that experiment works and how you can calculate these sort of angles. So imagine you have a mirror here and light hits it here and bounces or reflects here. This light is called the incident ray and this light is called reflected ray. Reflected means bounce and incident means hit. Now imagine there was a line such that this line is 90 degrees perpendicular to the mirror. This line is called the normal. Now the angle between the ray of incidence and the normal is called the angle of incidence, I. And the angle between the normal and the ray of reflection is called the angle of reflection, R. So what does the law of reflection say? It simply says that I equals R. And if you know even basic geometry, you can actually derive a lot from this simple equation, I equals R. For example, you also know that these two angles, I prime and R prime, are also equal. They're equal precisely to each other. And you know that a bunch of other angles are equal to each other and all that. Okay? So that is the law of reflection. And you can use it in many ways. Okay, so we learned about the laws of reflection. What are some applications for it? Well, one major application is in periscopes. So in a periscope, there are two mirrors placed like this. Light goes like this, hits one mirror, bloop, it goes down, bloop, hits one mirror and bloop, goes into the view hole. And these mirrors have to be at 45 degrees. If they even slightly deviate from that, the light will bounce totally differently in a way that can be predicted by the law of reflection. Now, another good example is when you have two mirrors and an object between them. The light will keep bouncing between the mirrors and you end up seeing infinite reflections of the objects. One great example is exactly the same as this setup, except instead of two mirrors, it used three mirrors. You might have heard of this experiment. It's called the kaleidoscope. Another great example, as I mentioned, is a kaleidoscope. As you can see, there are three mirrors surrounding the viewpoint. So anything that inside the viewpoint is going to be reflected an infinite amount of times. So that's why you're seeing an infinite amount of triangles. This is an amazing example of the laws of reflection at work. Okay, so that's the end of the video. Bye-bye, and I'll see you in the next episode of the Funtastic Academy. Wait a minute. What's the quiz question? Oh my god, I completely forgot the quiz question. The quiz question is simple. What is the angle of the mirrors in the periscope? Get me your answer and I'll tell you the answer the next episode of the Funtastic Academy.